Let's learn about absolute value functions. Absolute value functions are simply the distance from zero. The parent function of an absolute value function looks like this. These bars that you see right here simply mean how far away from zero is x, or what is x's distance from zero. So let's fill out a table. If x is -2, well, if we look at a number line, -2 is 2 spaces from zero. If x is -1, looking at a number line, -1 is 1 space from zero. If x is 0, it is 0 spaces away from zero. If x is 1, it is 1 space from zero. If x is 2, it is 2 spaces from zero. And if x is 3, it is 3 spaces from zero. So what's important to remember about absolute value functions is that its output is always the distance from zero. So we'll almost pause the video real quick and make sure you have your absolute value handout open in your class notebook. You will use this video to help you fill out that handout. All right, hopefully you have your absolute value handout open and you can fill it out as we go along. So the parent function for absolute value is y equals the absolute value of x. If I was to graph the parent function, it would be in a V shape. The general form of an absolute value function looks like this. A will be a number that controls how flat or steep the line is. H will control movement horizontally. And K will control vertical movement. Let's fill out some important information about our parent function. The domain of our parent function will be all real numbers, and the range will be all y's greater than or equal to 0. It has an x-intercept at the point 0, 0, and a y-intercept at that exact same point. This point right here is called the vertex. It looks like a corner, and that point is located at 0, 0. If we're talking about the end behavior, I see that as my x's get more negative, my y's are getting more positive. So I would say that as x approaches negative infinity, y approaches positive infinity. And here, as my x's get more positive, my y's are also getting more positive. So I would say as x approaches positive infinity, y approaches positive infinity. Let's take a look at another example. In this example, there are a couple things that are different. Here, my a is equal to -1, and I have a transformation. When I see x plus 2, that means I'm going to move left 2. So it's the exact same graph as our parent function, except it's reflected and left 2. So let's go ahead and graph it. It's reflected and left 2. So its vertex will now be here, and it's reflected over the x-axis. Now let's fill in some key information. Its domain is once again all real numbers, but now its range is all y's less than or equal to 0. It has an x-intercept at -2, 0, and it has a y-intercept right there at 0, -2. Its vertex happens to be -2, 0. That's this point right here, the vertex. And its end behavior is similar to our first example, but the opposite. Notice all of my y's are headed in the negative direction. So my end behavior is, as x approaches -infinity, y approaches -infinity. And as x approaches +infinity, y approaches -infinity. Go ahead and stop the video and make sure you have all your information filled out.